Hey, what's going on, guys? In this video we are going to see how to convert a complex number from rectangular format to polar format. Now let's look at an example. Let's say we have a complex number that is z is equal to -3 plus 2i, and if we draw this one graphically, okay, let's draw the graph for this one. Here we have y-axis, x-axis, and in the y-axis we are going to have our real part. So this is real part, and in the actually x-axis we have the real part, and in the y-axis we are going to have the imaginary part. And here we know that our real part is -3, so we are going to have the -3 right here. If we say this is -1, -2, -3, we are going to have -3 right here, and imaginary part is 2i, so we are going to have +2, so this is going to be 1, 2 somewhere here, okay. And this is the distance of this complex number. Now instead of writing like this, we can express this one in terms of the distance. That's what the polar format is, okay. So let's see how we can express this one in terms of distance. So to find the distance, we have to find out exactly where this one from here, and also this distance is not enough because we have to give the direction also, right? Because this distance can be anywhere. You can draw the same line around this graph. So to mention the exact location, we have to also give the angle from here to here, that is theta, okay. So this distance, to calculate this distance, we can use a tan theta, and in polar coordinates our x-axis is going to be cos theta, x-axis is cos theta, and y-axis is going to be sin theta, and this is our r, and this -3 is going to be equal to r cos theta, okay, and this 2 is going to be equivalent to r sin theta. Therefore we know that tan theta is going to be equivalent to r sin theta over r cos theta, r sin theta over r cos theta, and that is equivalent to r sin theta in our case, our y-axis, that's 2, and r cos theta is equal to -3, so -2/3. So from this one we can find out this theta angle, okay. Theta is going to be equivalent to tan inverse -2/3, and if you find this one, that's going to give you -0.59. But if you find the tan inverse for this one, that's not going to give you this angle, okay. So here I cannot say this is equal to theta. I should have used a different, like phi or something like that, but let's keep it as theta. But the only thing you have to understand is let's change this one into phi, because this angle is not equal to this angle, because we are using this line to calculate this angle. It means the angle is, since this is in radians and this is negative, it means this is in the opposite direction. It's starting from the origin, but this is in the opposite direction. Somewhere here the line extends like this. So if we draw a line like this, so this is going to be this radians, okay. Now we need this phi angle in order to express this one. So this is theta, this is phi. So what we can do is, this is 180 degree, right? For a straight line we know that the total angle is 180 degree, and if I add this one with phi, if I add this theta with 180 degree, that's going to give us this angle, because this is minus and 180 degree plus, so that's going to subtract this one and going to give us this angle. So that's what we are going to do right here. So we can calculate the phi by simply adding, okay, phi, we can calculate the phi by simply adding this theta plus 180 degree. Since this is in radians, we have to add 180 degree in radians. In radians 180 degree is equal to phi, so this is going to be theta plus phi, and this is this theta we already know, that is 0.59, and phi value is going to be 2 point something, right? 2 point something. So if you plug this value, you will get 2.55. so this is going to be our phi value. Now we have found out the location from here to here, and the next thing is we have to express this distance, And to express this distance, we can use the Pythagorean theorem to find out this r. R square is going to be equivalent to 2 square plus this distance is 3, right? 3 square. So r is going to be equivalent to 4 plus 9, and that's going to give us square root of 13. Now we have the angle and also we have the r distance, so we can finally express our final answer. So let's express the final answer as z. Yes. Therefore z is going to be equivalent to square root of 13. In the x-axis we are going to have cos, and the angle is 2.55, and in the y-axis this is square root of 13 sine 2.55, and this is going to be our final answer. And also this is imaginary number, we have to put I, okay, because y-axis is imaginary number, so we have to put an I. And here we can simplify, like we can take the square root of 13 common. If we take square root of 13 common, that's going to give us square root of 13 cos 2.55 plus sine 2.55, and that's I, okay. And that's how we convert a complex number from rectangular format to polar format. I hope this helps. Thanks for watching.